Hi everyone. As part of today's session, I will cover object-oriented programming in Python. Okay. So object-oriented programming is one of the paradigm that organizes code into classes and objects. Uh, so uh, in object-oriented programming, classes and objects are two important things. Okay. So what to understand object oriented programming, first we need to understand what is class and what is object. Okay, so class is blueprint or template of creating objects. Okay, so class just provides template. This is logical represent, in other words we call class as logical representation of objects. Okay, and object is instance of class. Using class, by referring class, we create the objects. And objects are the real entity created from class blueprint. So let me explain class and object with some example. Okay. So if you consider animal have property like legs, uh, hands, eyes, right? So animal is one of the class, and property of animal, what animal have animal have legs, hands, eyes, right, mouth. So all these are properties of animal, but animal is not a physical entity. We are just uh, declaring it. And if you see dog, cat, those are real entities, those are the objects. And if you create object from class, right, then each object you have to initialize. So initially I explained it, animal have property like legs, hands. So each if you consider dog and snake, dog have hand, legs, but snake don't have hands and legs, right? So it is not necessary that all the objects have same property, right? Animal will provide just blueprint, and using that blueprint, objects will implement its own implementation. Means in case of dog, right, it have its own property, like it have two hands, two legs. But in case of snakes, zero hand, zero legs. So objects objects property will be different. So class will just provide uh, properties, and according to object will implement those in its own way. Okay, so just class provides blueprint, and it is not a physical entity. Class is not a physical entity. It just provides the blueprint or template on how to create the objects. And objects are the real entities which will be created from class. Okay, so this is about class and objects. So I will explain class and object in detail with practical example also. But let me cover pillars of OOPS first. So OOPS have four concepts or pillars. Okay, those are inheritance, encapsulation, polymorphism, and abstraction. So in this session, I will just cover just I will explain, but in further session I will cover each concept, each pillar with practical examples. Okay, but in this session I will just explain high level overview on each pillars. So first pillar of OOPS is inheritance. Inheritance is a mechanism where uh, we can reuse code from existing class. So class is there, and it have some property, and I am creating one more class. That class also have same property of existing class, but it have along with uh, existing class, it have some extra properties. Okay, in that case I need not to write mm, all the behaviors what existing class have. I can reuse existing behavior of existing class, and I can extend new class with extra behavior which existing class don't have. So inheritance is reusing code from existing classes. Okay. uh, and next pillar of OOPS is encapsulation. Here, hiding the data and controlling the access. So using encapsulation, we can control the access of variables and methods of a class. If you want to restrict some classes, other classes don't want to use its own property, then we can hide the property as well, just for security purpose. Okay. Next pillar of OOPS is polymorphism. Uh, so what is polymorphism? Polymorphism is one interface, many implementation. Like depending on uh, s- uh, same method behaves differently in different situation. Okay, so this is called only one time you are implementing, but behaving differently on different situation. Okay, so behaving differently in a different situation, but the implementation is one only. So that is called polymorphism. And last pillar of OOPS is abstraction, where we are hiding unnecessary details. And for example, if you consider car, driver need not worry about how steering works, how brake works, how brake is implemented inside, how steering is implemented inside. Driver have should know how to drive it, how to use the steering or brake or clutch. That much information is enough for driver, right? He need not worry about how it is internally implemented. So we are using abstraction, we can hide implementation, and we can show only necessary details. Okay, so let me explain class and objects in detail with practical example. So I have written this program to explain class and objects. So you can declare class using class keyword, and student is class name. Okay. So student class have some properties. Okay. Like student will be having name or roll number, and I'm just declaring. If you assign none means if you don't want to assign any value, you are just, if you want to just declare the variables, then you can use none keyword. Okay, you are not assigning anything, you are just declaring the variables, and you are assigning values later. Okay, then you can go for none option. Here I'm just declaring two variables. So student have two properties, that is none and roll number. So student is class, right? It just provides blueprint or template. So student should have roll number and name, that is property of each student. This is not a physical entity. Student is not a physical entity. Okay, it is just logical representation. And it have one method, that is student details, where I am just this method, under this method I am just printing student name and student's roll number. Okay, so this is how you have to declare the uh, class and assign the properties and methods. Okay, and student is just logical representation. And with this student class, right, I can create objects, and objects are real entities. Okay, student is just blueprint or template. So how to create object for student? In line number 8, I created one student object, which is Rahul. Okay. So you have, this is outside of class. Okay, line number 8 is outside of class. So here I'm creating object using student class, and Rahul is object of student class. Okay. um, so if you consider Rahul is physical entity, right? So Rahul is object, student is just blueprint or template, which is not a physical entity. So this is the main difference between class and object. So if you consider Rahul have his name and his roll number, which is not same as other students, right? Rahul have his own property. Like Rahul's name is not similar to other students' name. Rahul roll number is not same as other students' name, right? So line number 8, I created the object, and I am for this or Rahul object, right? I want to assign name and roll number. So instead of Rahul, I will just differentiate between object and variable, right? I will just initialize it as obj. This is Rahul object, and Rahul object have his own name and his own roll number, which I am assigning at line number 9 and 10. 9 and 10. I'm assigning Rahul object's name as Rahul, and Rahul object's roll number as some integer variable, which is roll number. And I'm calling student details. So this will call student details, and let me explain self. Self will be initialized with object reference. Here Rahul, right? Rahul's object will be assigned to self. Okay. So because you are calling Rahul student method using Rahul object, right? So self method is initialized with Rahul's object. And what name and roll number I assigned to Rahul object? Rahul and 206789 is roll number. So those will be printed in line number 6. Rahul's name and Rahul's roll number will be printed here, because I am passing Rahul's object to self, and self, using self I am fetching name and roll number. So whenever I'm calling student details, I will get this information will be printed, like student name is Rahul and roll number is 206789. So this will be the output. Okay, so let me execute. Okay, so I got output like at line number 12, I am calling the method of student details, and I am printing details of Rahul object. So this is how classes and objects are created. Okay, so class provides just blueprint, and objects provide objects are real entity, and class just logical representation of objects. Okay. So if, here, right, let me explain constructor method in class. So each time whenever you are creating objects, right, so you will be creating multiple student objects. Like again, you need not to each time define name, roll number for each student. While initializing object itself, you can provide uh, what attributes object should have. Okay, so this is one way to initialize the objects, means attributes of particular object, right? I'm just creating object, and name and roll number I am assigning here. So instead of assigning later, during object creation itself you can assign. So how can I do that? Using constructor, we can uh, using constructor, we can assign we can initialize variables of a class, okay, or objects. So Python provides one special function, that is init. Two double underscore and init, and again two underscore, okay. This is special function. This will be called during initialization of object, okay. So it takes you can provide parameters also. So what I'm implementing is, during creation of object only, I want to pass name and roll number, so that role and line number 12 and 13, I'm initializing a role. I don't want to initialize later. I During creation of object itself, I want to initialize. So I will comment out line number 12 and 13, okay. I don't want to initialize later. During creation of object itself, I want to initialize name and roll number of Rahul's object. So you have to create this init function in student class to achieve this. During object creation only, you can assign properties of Rahul's object, okay. So it takes name and roll number, right? And I self dot, so Rahul self means Rahul's object, okay. This object, this name I am initializing with whatever this name is, whatever parameters is passed, value passed in name parameter, and Rahul's roll number equal to whatever is passed in this parameter. So init is one of the special function which will be called during initialization of objects. So now, instead of assigning values of name and roll number later to Rahul object, I can pass name as Rahul here itself, and roll number 206789 something. Okay, now whatever uh, line number 14 and 15 were doing, right, same job init method is doing here, okay. So init method will be called while initialization of student object at line number 13. You have to at class name parameter itself, you have to pass what attributes you want to initialize. So Rahul is I am providing first parameter value as Rahul, second parameter value as roll number, right? So same, Rahul is assigned to name, and roll number is will be assigned to this roll number, and same will be initialized to I'm using self, right? So Rahul objects name will be assigned with Rahul, and Rahul objects roll number will be assigned with this 206789. Okay, so I have commented out the 14 and 15, okay. And again I am calling student details, means it should display student Rahul objects name and roll number, okay. So this init method is called constructor as okay. So this will be called during initialization of objects. So let me run it and see whether I will get same output. I got same output. So I have not in case of student details, I explicitly called student details method, but init method I have not called. Init method will be called during initialization of objects, okay. We can't call explicitly, okay. So during initialization of object, it will call and it will execute whatever statements written in init method. Init method is a special method, or we call it as constructor. Okay, I hope constructor is also clear, and purpose of student object is also clear. That's it from today's session. Thank you. Bye.